Hi everyone. As usual, hope you're all doing okay. Hope you're all coping with this lockdown. So we're moving on this week to talk about resistors in series and parallel, and we're going to carry out sort of a virtual experiment. As in, I'm going to put numbers in, and we're going to, work out relationships for resistors in series and resistors in parallel. So following on from last week where we were talking about series circuits and parallel circuits, so the next stage is we're going to look at what happens when you combine resistors in series. So as I say, we're going to carry out this virtual experiment to try and get a relationship between the individual resistors and the total resistance when we connect them in series. So we're going to make up three resistors, three values. We're going to call them R1, R2, and R3. Then we're going to measure each resistance of each resistor individually using an ohm meter. And then we'll connect all three resistors all together in a series circuit and measure the total resistance using the ohm meter as well. So this is just doing exactly what we'd be doing in class, except we can't do this. There's no simulation software that I could find that would do this to the way I wanted to do it. So this is why I'm doing it kind of old school like this. But we'll carry on and we'll see how we get on. So the first resistor is R1. Hopefully you can see that. And remember, we can just measure its resistance straight off by connecting it across or to an ohm meter. And so a value of R1 is 6 ohms. R2 is another individual resistor which has got a resistance of 3 ohms. And then the third resistor, R3, has a resistance of 4 ohms. And we're going to use these values throughout the whole of this PowerPoint, and hopefully that will make sense when we go through it. So there's just a table to summarize what we've just done, that we've got three resistors that we've measured individually with the ohm meter, and on the next page we're going to, or next slide rather, we're going to connect them up in a series circuit. So as I said, so there are the three resistors, R1, R2 and R3, all connected together in a series circuit. We know it's a series circuit because there's no junctions, there's no different paths, there's only the one path. We've got the ohm meter connected like that, and so that ohm meter there will read the total resistance of this circuit with those three resistors all connected in series. And what you find is that the ohm meter reading in this circuit, this experiment, is 13 ohms, which kind of makes sense because this is going to give us a relationship for the resistors. So if you remember, R1 was 6, R2 was 3, and R4 was 4. And so therefore, if you add up 6 plus 3 plus 4, it gives you 13. So this gives us the equation, the relationship for connecting resistors in series. Couldn't be any easier that if you connect resistors in series, all you do is you just add the resistors up. And it's in this form that it's got plus and then dot dot dot, because it goes on for however many resistors you have in series. So if you've got 10 resistors in series in a circuit, then it would be plus R10 at the end. So the total resistance of resistors in series is just given by adding up the total resistors. And so if we just double check again, so 6 plus 3 plus 4 gives us 13. And when we connected this ohm meter up to this circuit, it registered 13 ohms as well. So resistors in series is pretty straightforward. And the other thing you can remember is that when you add resistors in series, that makes the total resistance of the circuit greater, which kind of makes sense. So I've got a wee question I'm going to ask you to think about for a minute. If we added more resistors, kept adding more resistors into a series circuit, what would happen to the current in the circuit? So I'll give you a second or two to think about that. Can't give you too long, but so the way to answer this is think about, well, what's going to happen to the resistance? Well, we've just said in the previous bit that if you add more resistors in series, the total resistance gets bigger. And if you remember from a couple of weeks ago, if the resistance increases, what happens to the current? The current would decrease because we've increased the total resistance of the circuit, and so the current would get smaller. Okay, so this is where it gets a bit trickier because we're now going to deal with what's called resistors in parallel. Now we're going to use the same three resistors that we've been talking about in the previous slides, where we've got R1, R2 and R3. Just to remind you that R1 is 6 ohms, R2 is 3 ohms and R3 is 4 ohms. But this time we're going to connect, we don't need to measure them again because we've already got them. We've got that these are their values. So we're now going to connect the resistors in a parallel circuit and measure the total resistance using the ohm meter. And so when I do that, that's the circuit there, which we can tell it's a parallel circuit because there's these wee junctions here. There's more than one path around the circuit. So these resistors are connected in parallel. And the ohm meter here is going to give us the overall total resistance of this circuit in this case. So the reading on the ohm meter in this circuit is going to give us the total resistance of the resistors when it's connected in parallel. And what you find is, perhaps, maybe not, a wee bit surprising that the total resistance is 1.3. There doesn't seem to be any relationship, any kind of connection between the 6, the 3 and the 4. In the previous one, when it was resistors in series, it was quite easy because you obviously add up 6 plus 3 plus 4 and that gave you 13. Had to think about that there, never mind. But when it's in parallel, the resistance, the total resistance actually gets smaller. And that's maybe a wee bit difficult to understand or difficult to accept, but that is what happens, okay? And for that reason, if we did that same question that I asked in the previous slide, what would happen if we connected more resistors in parallel to the current in the circuit? I've not asked the question here, but that would be what we could ask. Then what would happen to the current? Well, clearly if you add more resistors in parallel, then the total resistance decreases. And in actual fact, this total resistance here is always less than any of the individual resistors. So that's a kind of quick double check. If you have that in the back of your mind, in your memory bank somewhere, that when you're adding resistors in parallel, the total resistance is always less than any of the individual resistors. So that 1.3 had to be less than 3 ohms there. And if that was the case, if you add more resistors in parallel, the resistance decreases. So the current in the circuit, if you had 3 resistors like this in parallel, then the current would increase. So it's the opposite of what happens in the series circuit. So this then leads to the relationship for resistors connected in parallel, which is a good bit more complicated than it was for resistors in series. There's the relationship there, that it is that 1 over the total resistance equals 1 over R1 plus 1 over R2 plus 1 over R3. And then again, there's a whole dotted line thing because it goes on for as many resistors in parallel as you were going to connect. So you might say, well, how do we get this relationship? Well, let's use the results that we've got from our virtual experiment to check the relationship. So this is the formula, and we're going to just check if that gives us the right values that we were using in the experiment. So in our experiment, remember, R1 was 6 ohms, R2 was 3 ohms, and R3 was 4 ohms, okay? So if this relationship is correct, so 1 over 6 plus 1 over 3 plus 1 over 4. And on the next PowerPoint, I'll go into how you put this into the calculator, various ways you can do it. But just for today, we're going to kind of do a quick recap and get to this point here. So if you do 1 over 6 plus 1 over 3 plus 1 over 4 in the calculator, it gives you, on your calculator, it'll say 3 over 4. Now, again, as I'll say in the next PowerPoint, and probably repeating myself, that's not the final answer because that's what 1 over the total resistance is. And so to get the total resistance, what you need to do is switch them round. So it's 4 over 3. So the total resistance is 4 over 3, which equals 1.3, which, if you remember rightly, is exactly the same as the value we got in the experiment on the previous slide. So the total resistance is 1.3, and that's the relationship that you have to use for resistors in parallel. And hopefully you'll see in the next PowerPoint, I'll give you a bit more detail about this and go over a couple of examples on it as well. So over to the next PowerPoint.